This video is on arenes or aromatics. So these are compounds that are related to benzene. So benzene, it's very important you understand that benzene is C6H6. So this structure would be 6 carbons in a ring. Okay, so I'm going to fully draw it out. And it has alternating double bonds. So, and it doesn't matter where you put them, and I'll come back to that in a second. Oops. Okay, so this right here, this is benzene. So each carbon would have 1 H. So 6 carbons, 6 H's. So the condensed version that you'll typically see, you'll see one of these two formats, is you'll see this hexagon drawn, and you'll see double bonds on alternating sides, like this. Now another way you'll see this is, again, if I draw the hexagon, you'll see it with a circle drawn in the middle. And this is because this is what we call a resonance structure, meaning that no one picture accurately shows the structure. It actually exists as the double bonds here, like I drew them, but also in the different sites. So the opposite. So instead of here, it'd be here. Instead of here, it'd be here. This. So these go back and forth in between each other. They both all exist, which is why typically you'll see this one right here. All right, so the word aromatic comes because they first, all of these had really strong or pleasant fragrances, nice smells. But the ring actually doesn't have anything to do with the smell. That was just kind of a coincidence. Many of these have common names like naphthalene, toluene, anthracene. Toluene is one you'll kind of see a lot, and it's kind of weird to say that, right? Toluene. And that is when you have your benzene ring like this with one methyl group, like this. Okay, so how do we name these? All right, so if an alkyl group substitutes a hydrogen atom, so instead of 6 hydrogens, you have 1 or any number less, the structure is similarly named like a branched alkane. So you're going to first obtain the smallest possible numbers to indicate the location of the branched alkane. So you still want to have the branches have the lowest numbers. So you're going to start anywhere on your kind of cyclical structure there so that your numbers are the smallest. You can go clockwise, counterclockwise, doesn't matter. And if there's only one substituent, numbering isn't required because no matter where you put it, that's considered site 1, carbon 1. You're going to identify the various branching groups attached to the continuous change of carbon by name, so like methyl, chloro, whatever that may be. If the benzene ring itself is a branch, which it can be, then the benzene ring is called a phenyl group, and this is important. IB wants you to kind of know this. All right, so an example would be this. If this was my chain here, instead of saying benzene, well, with benzene with a butyl group. So instead of saying butyl benzene, the actual name for this would be 1-phenylbutane because you've got your carbon right here with your branch. Okay, this carbon is the first one, and you've got a phenyl or a benzene group off of it. So 1-phenylbutane. Okay, all right, so let's do some examples, some practice. So let's name this first one. So this right here is my benzene. Okay, so that's like my parent chain. And then we have this one branch or substituent. This is my methyl. And it's off of 1 carbon. There are no other branches. So I don't need to say 1-methyl. I can just say, or it's better to just say, methyl benzene. Okay, the 1 isn't needed when you only have 1 substituent. This next one here, all right, so again, I have a benzene. And then up here is an ethyl group because it has 2 carbons, okay? And again, I don't have any other branches, so I'm just going to say ethyl benzene. Same rules would apply in terms of numbering and like alphabetizing as it would for like alkanes. All right, so now I want you to add this one into your notes packet. Let's draw this one. 1-chloro-3-methylbenzene. So Benzene, right, gives me that ring structure, okay, with the alternating double bonds. I have a methyl group on the third carbon, and I have a chloral group, a chlorine, off the first. Okay, so I'm going to draw my parent structure first. So here's my benzene. All right, and then I'm going to put my chlorine and my methyl on. It doesn't matter where I start. Wherever I start is my 1. So let's just put it here. Here's a chlorine. And then if that's 1, it could be 2, 3, so it'd be here. Or it could go the other way, 2, 3. It would be here. Same thing. It's just looking at it from the other side. So it doesn't matter. I usually just go clockwise. And here's my methyl group, CH3. So that is Arenes or aromatics. It's really all about the benzene, and then make sure you remember that when the benzene is the substituent, it's called a phenyl.